In today's video, we want to talk about how to find the inverse of a one-to-one function. What is one-to-one function? One-to-one function basically says when you have x, you can only correspond to one y. That's for any function satisfy that condition. But you also, if you have any one value, then that's one value can only correspond to one x value. So that's the reason we call this one-to-one function. The question here is how we actually find a inverse function if you already know this function is a one-to-one function. We basically follow the following three steps. 1. Write y equals fx. Solve this equation for x in terms of y, if possible, and interchanging x and y, and the resulting equation is y equals f inverse x. So let's take a look at the specific example. First example, fx equal to 4x minus 2 divided by 3x plus 1. And remember, we follow the three steps there. So first, we rewrite this as y equal to fx, which is 4x minus 2 divided by 3x plus 1. Okay, so here, remember, the second step is solve for x from this equation. So in order to solve this equation for x, we multiply 3x plus 1 to both sides of the equation. Okay, so we're going to have 3x plus 1 times y equal to 4x minus 2, 3x plus 1 multiply x, 3x plus 1. Okay, so here 3x plus 1, 3x plus 1 reduced. And so now you can see after reduce, you do not have a fraction anymore because that's equals 4x minus 2 there. So now what we try to do here is solve for x. Let's distribute y to each of this term. So here I have 3xy plus y equal to 4x minus 2. Go ahead to solve for x. In order to solve for x, you need put all the terms involving x together. So let's subtract 3xy from both sides, add 2 to both sides. So we subtract 3xy, subtract 3xy, we add 2, add 2. So now that's cancelled. You can see on the left, you have y plus 2. On the right, that's 2 cancelled. You have 4x minus 3xy. So now we want to solve for x. What we try to do here is we factor out x. We factor out x. Here you have x and 4 minus 3y. When you factor out x, 4 left. When you factor x, 3y left. So y plus 2. So now both sides, you use 4 minus 3y to divide both sides. So you have x equal to y plus 2 divided by 4 minus 3y. When you use 4 minus 3y divide that side, 4 minus 3y actually cancelled. So that's the reason you get the x there. Okay, so that's basically, we finish the second step. This is the first step. This long process, this is the second step done. The third step here, simply, okay, you need interchange x, y. Means in the y and x, you simply change. So if you change that, you're going to have x plus 2, 4 minus 3x equal to y. Interchange x, y there. So now finally, you rewrite y as the inverse f of inverse. So you get x plus 2 divided by 4 minus 3x. So this is the so-called inverse function. Okay, we find the inverse function of the original function. So 4x minus 2, 3x plus 1 there. But the question here maybe one is 4x minus 2 divided by 3x plus 1 is one-to-one function? And actually it is. If you graph it, okay, you find this graph passes so-called the horizontal line test. So here is the graph. Okay, that's the graph. I have this here, you can see, and you draw any horizontal line, and that will not intersect with the graph twice. So it is one-to-one function. But you say, and so now let's take a look. Next question here. This function, you gotta be careful. We know 4 minus x squared is a quadratic function. When you have a quadratic function, you realize quadratic function actually, for this case, the graph looks like this here. Okay? But since this case, it asks us x must be greater than or equal to 0. So that means when you graph this function, you cannot graph that side. That side is not part of the f. F only starts from 0 to infinity, which means only this half of the graph represents the graph of this function. So that means you can see it pass horizontal line test because that side, you don't have that side. Okay, so that tells us this is a one-to-one function. So when you have one-to-one function, so you can find its inverse. Same as before. Okay, you get y equal, that's first step. You write y equals 4 minus x squared. That's the first step. The second step, you try to solve for x. Okay, solve for x. Go ahead to solve for the x. Okay, what you have here, subtract 4 from both sides, you get y minus 4 equals negative x squared. Multiply negative 1 to both sides, you get negative y minus 4 equal to x squared when you multiply negative 1 there. Okay, so this can be written as negative y plus 4 equals x squared. Now I square root both sides. Square root both sides, I'm gonna have square root and negative y plus 4. We can write this as 4 minus y equal to x. Normally, when we square root both sides, we're gonna have a plus minus there. Okay, we're gonna have plus minus there. But this case we don't. The reason is because we know x must be greater than or equal to 0. X must be greater than or equal to 0. So that means we don't have a negative one. So we only have a positive one. So that's the reason. Okay, so we just write this. And since x greater than 0, greater than or equal to 0. Okay, so now that's the second step. The third step, we interchange x, y. So here we're going to rewrite this as y. So we write y equal to square root 4 minus x. 4 minus x. Okay, so that's what we have here. And now, finally, we have to write the y as f inverse of x. F inverse of x equal to square root 4 minus x here. Okay, 4 minus x there. So that's it. We have so-called in the inverse function. Okay, square root 4 minus x is the inverse function of 4 minus x squared when x greater than or equal to 0. Okay, but notice what happened here for this function, and the domain is x greater than or equal to 0. The range actually is from negative infinity to and 4. 4 is included. But for this function, you can see the domain, and actually is from 4 the domain is from negative infinity to 4, and the range is from 0 to infinity. Okay, and you can see here, because when you interchange x to y, so that's reason, so their domain range just simply change. So original function's domain, you can see, and now it become the inverse function's range. Original function's range becomes and the inverse function's domain. Okay, because you simply exchange x and y there. Okay. So now let's look at the last problem. Fx equals 2 plus square root of 3 plus x. Is that one-to-one function? Yes, this is a one-to-one function. So here, let's see here. And fx equals 2 plus square root of 3 plus x. We write as y equal to 2 plus square root of 3 plus x. Go ahead to solve for x. Subtract 2 from both sides, we get y minus 2 equal to square root 3 plus x. Square both sides, we get y minus 2 squared equal to 3 plus x. And solve for x, subtract 3 from both sides, you get y minus 2 squared minus 3 equal to x. So that's the first step. That's the second step, solve for x. The third step, interchange x and y. So that means I'm going to write this x as y and write the y as x. Are we done for this case? Not yet. So here you say I'm going to write f inverse equals x minus 2 squared minus 3. Are we done for this case? Okay, no, it's not done here. What happened here? You see, x minus 2, whole thing squared minus 3. If you graph this function, okay, this graph actually, when x equals 2, y equal to negative 3, okay, and so here the graph actually looks like this way. If it looks like this way, so that tells us that is not one-to-one function. Okay, one-to-one function. If it's not one-to-one function, so you can't have inverse. Okay, you can't. You say, oh, that's this function. It doesn't matter. When you have an inverse function and original function, both must be one-to-one function. Okay, so this case is not one-to-one function, so it doesn't have inverse. Okay, so here now we have to indicate its domain and range. Look here, for the original function, its domain is x must be greater than or equal to negative 3. Okay, or in other words, you're going to write negative 3 to infinity. And for the range for this function is simply y greater than or equal to 2, because that is greater than or equal to 0 plus 2, the greater than or equal to 2. So you have, and that's from 2 to infinity. Okay, remember, original function's domain becomes a new function's range, inverse function range. Original function's range becomes domain of the inverse. So now domain of f inverse in this case is 2 to infinity. So in that way, so here that tells us you don't have that side of the graph. You only have that side of the graph because this is from 2. That's x equals 2 and greater than 2. Okay, so then that is one-to-one function. So that is the kind of a function you got to be very careful. After you finish, you have to indicate what is the domain, because if you just simply stop here, this is not one-to-one function without indicate its domain. Okay, so that's the end of this video.